Hello friends, welcome to our channel Mirror Neuron, which means watch and learn. And today we are going to look into the part 2 of our market basket analysis or recommendation system. Now in the last video what we have covered is how are we going to prepare the number of item pairs, and say for example we had two orders and we have ordered different items, so we would like to see the count of each of those item pairs. Right now, because we are taking a huge data set and probably some of the items will be ordered only once or twice or maybe very few times, so those information are not going to be very much helpful for us in order to recommend those products, right? Because they're just very sparse in the number of times they have been ordered. For example, that's what we are going to explain next. Is, say for example we have 5 orders, and you can see the number of items or the different items that has been ordered in each of those orders. So if you see the order 1, we have apple, some exotic fish, broccoli, and the order 2 we have egg, broccoli, chocolate, and so on. So now I want to count what are the different items that has been ordered and how many times. So if you see, apple has been ordered 4 times, broccoli has been ordered 5 times. In fact, all the orders have broccoli in it. We have egg 3 times, chocolate 2 times, exotic fish only once, and pickle only once. Now in this count we can see that exotic fish and pickle appears very limited number of times. That means they have been ordered only once in this particular example. So we can actually remove this kind of items which are very less number of times that has been ordered, right? Unnecessary, we don't have to do so much of analysis. Now this could also trigger another idea that we might want to recommend this product so that we can increase the upselling and cross selling, right? Could be interesting to recommend something new for the customers. All right, now if we have to do some analysis, what we are saying that if the item is not ordered more than 2 times, just remove those items. So you can see we can remove chocolate, exotic fish, and pickle. We're just creating a small filter here. So we are left with apple, broccoli, and egg. And if I count the pair with the remaining items, which are apple, broccoli, and egg, I can see that apple, broccoli appears 4 times, egg and broccoli appears 3 times. And I have totally removed the chocolate, exotic fish, and pickle. All right. Now, in order to continue with our analysis, we have to understand 3 terms here. Not that it should be only these 3 items. So there are many other things that can be used for building our recommendation system, but commonly we use support, confidence, and lift. And we'll see with examples and see few basic calculations through which we'll understand all these definitions. So the first one is support. So support is the ratio of a item pair. That means how many times that item pair has appeared in our order history and what is the total number of orders. Very simple. So if you see in my above order, the total number of order is 5. So if I just scroll a little bit up, so you can see there are total number of 5 orders, right? And in that 5 order, the apple and broccoli appeared 4 times, right? So my support basically gives the ratio of number of times the pair of apple and broccoli occurred within the entire order history. That means each apple and broccoli should be in the same order, of course. Now that divided by the total number of orders, so that is 4 out of 5. That means 80% of my order had these 2 combinations, apple and broccoli. That is support. I think very straightforward, right? Next comes the term confidence. So in order to understand confidence, we have to take 2 items, X and Y, for example, and we can take examples such as apple and broccoli. So the confidence basically gives the percentage of time Y is purchased given that X was purchased. It's very similar to, remember, the naive, the Bayes theorem, right? Given that what is the chance of picking one item given that another item was already selected. So if I take the example of apple and broccoli, so I want to ask what is the chance that somebody will purchase broccoli given that person has already purchased apple, right? But keep in mind that the confidence matrix is basically directional. So if I ask what is the chance that somebody will pick broccoli given that apple was picked, is different, then what is the chance that apple will be picked given broccoli was already selected? So if you see, there are two different things actually, and we'll simply solve it by a simple calculation. So the confidence that broccoli was selected given apple was already selected, what we can see is it's just a simple ratio of the support apple and given the broccoli is already selected divided by the support of broccoli. So that means there are two different calculations now. So one will give you 100%. If you see here, the confidence of y over x is nothing but the support that broccoli will be selected given apple was there already, divided by how many times apple was selected in the entire order history. So if you see, the ratio is 1. So confidence can range between 0 and 1. So 0 indicates that y is never purchased when x is purchased. Sorry, I have written a here. X is purchased. So that means I can say that if the confidence of say whenever I purchased apple, I never purchased broccoli. So that will give a confidence of 0. And if I get a confidence of 1, which I can see in this case, is whenever I purchased apple, I have also brought broccoli along with it. Okay, but the other way around could be different. So what is the chance that I have brought broccoli, then what is the chance that I'll be buying apple as well? So those are two directional things and different things. Okay, and confidence will lie between 0 and 1. Okay, so the third concept is lift. So lift is, again, unlike confidence, it's not a directional metric. Okay, so that means lift of x given y is equivalent to lift of y given x. Okay, so the question is now, what is lift? So I'll take the same order list again. So we have 5 orders. Now in order to explain lift, we want to know that whenever two items are together in a order, is it a random chance or there is in fact a relationship? That means if I pick apple and egg in from my order history, does apple and egg is just a random event that they are together in the order, or is it that the customer really put some thought behind it to get apple and eggs together? So we want to study that relationship. So in this order example, so say we have two items, apple and eggs, and we believe, say, they have 0 relationship, right? So what we are going to do is, like we saw in our probability, what is the likelihood that I'll be picking both apple and egg? So I can see that apple was there 4 times in my order out of 5. So 4 by 5 is the probability that I'll be picking apple, and there is a 60% chance that I'll be picking egg because egg was ordered 3 times out of the 5 times, right? And if I multiply them, then I get 48%. That means it is a random chance that apple and eggs are going to be together in an order. Simple and straightforward. Now I want to know whether this apple and egg, is it totally random? If it is random, then it is going to be 48%, right? So what if I get a probability of more than 48%, and what if I get a probability of less than 48%? That's what I'm going to study. And that's where we have put 3 buckets. So if lift is equal to 1, that means there is no relationship between apple and eggs. But when we say lift is equal to 1, that means what is in the denominator? The denominator is that 48%. That means what is the likelihood of getting both apple and eggs in a order, assuming that there is no relationship. So I want to do my reference with basis of that 48%. Okay, and if lift is greater than 1, then that means how many times greater than 4.48%? Sorry, how many times greater than 48%? I'm talking about how many times, okay, so that I can talk about ratio. So lift is greater than 1 means there is a positive relationship for both items to be together. So that means apple and eggs occur together more often than the random. Okay, so for example, if I get a 78% chance, so that means I will divide 78% divide by 48%, and whatever the value is, that is my lift, and it shows a positive relationship. Similarly, if I have lift less than 1, then there is a negative relationship between apple and egg. That means they are not together, not just because of any random reason, but because there is a particular reason, and that is why they are not together. Okay, so the same calculation. So what is the, if I take this example of 5 orders now, so you can see what is the chance of ordering apple. We have already seen it's 4 upon 5, 80%. What is the chance of ordering eggs, which is 3 over 5, which is 60%. And how many times apple and eggs has been ordered in the entire order history? Again, you can see the pair gives you 2 upon 5 because there were two orders where we have ordered apple and egg together, and that is 40%. Now if I just simply take the ratio of all these numbers, 40 divided by 40, 80% into 60%, which is 0.83, which is less than 1, that means there is a negative relationship between apple and egg, and it is not random. So that means there is a reason why apple and eggs are not bought together in this particular example, of course. And this leads us to the conceptual understanding that we can use these three concepts in our actual data set and see, based on these three definitions, can we find out items which we can recommend to our customer. So in our next video, we are going to actually start implementing these concepts in our data set, and we will also see how such huge volume of data that we have can be processed within a 8 GB laptop, right? So that you can also practice at your end as well. Alright, so thanks for watching, and please subscribe to our channel and share it with your friends and colleagues who are interested to know more about machine learning and especially building recommendation system. This will be very helpful for all of you. Also, if you share your feedback, it will help us improve our video and the future projects that we are going to make. Thanks again and have a great day.